on these, but let's take a look at them. I know they're taking a little bit longer than I had thought. I would maybe overdid them a bit. But let's look at the first 9 up here. Now, the first 9 don't require your calculator. All they require is identifying the sides out of the diagram that need to be included for that function. So for like number 1, sine of angle B. Sine is opposite over hypotenuse. If this is angle B, of course, the hypotenuse is always, for this triangle, the 17. The opposite would be the 15. That's across from B. So that would be just 15 over 17, opposite over hypotenuse. Something like that. I'll just leave it as a fraction. Either way would be acceptable. Cosine of A. Well, here's angle A. Cosine is adjacent over hypotenuse. So 17 is still the hypotenuse. So it's adjacent now would be the 15. So 15 over 17. Tangent of angle B. Well, B is up here. Tangent is opposite over adjacent. So opposite is the 15. Adjacent is the 18. So 15 over 8. Secant of angle A. Secant is hypotenuse over adjacent. So if this is angle A, adjacent is the 15. So it's 17 over 15. So the key here is keeping track of opposite and adjacent for the angle that you are looking at. Remember, it changes depending on which angle you're looking at. Cotangent of A. Cotangent is adjacent over opposite. 15 over 8. Now, some things to notice so far. First of all, cotangent of A equals tangent of B. Why? Well, because A and B are complements, so the tangent of one equals the cotangent of the other. Sine of B equals cosine of A. Again, co means of the complement, so since A and B are complements, the sine of one equals the cosine of the other. Secant of A is the reciprocal of the cosine of A. Cosine of A is 15 over 17, secant is 17 over 15. So let's keep going here. Cosecant of A. Cosecant is hypotenuse over opposite. 17 over 8. Secant of B. Secant is hypotenuse over adjacent. And for B, that would be 17 over 8. You got it. Cosecant of B. Cosecant is hypotenuse over opposite. So for angle B, that's 17 over 15. Tangent of A. Other way. Cotangent is adjacent over opposite. Tangent is opposite over adjacent. If you don't have those definitions written down somewhere, even if you do have them written down somewhere, I would suggest maybe taking like the last page of your notebook or something where you can flip to it really quickly and writing them all out so you have them. Because those definitions, opposite over adjacent, hypotenuse over adjacent, and all those, are going to pop up a few times over the next few weeks. Now, these next ones, 10 through 14, are totally separate from those first 9. The first 3 here, 10 through 12, are just asking that you identify the meaning of the cofunction. Sine of 17 is going to equal the cosine of 73. Where did 73 come from? Complement, 90 minus 17. Tangent of 52 is going to equal the cotangent of 38. Again, 90 minus 52. Cosecant of 71 is going to equal the secant of 19. Again, complements. Arcsine. You might also see it more familiar written like that. Or like that. Or the way we saw it mostly yesterday. Like that. All four of those notations are asking you to do the same thing. What angle has a sine of 0.85? So it's just second sine 0.85. 58.21 degrees. Arc secant, again, that's just saying inverse secant of 2.5 or saying secant of A equals 2.5. It's asking you to do an inverse secant. Now remember, inverse secant uses cosine. So it's inverse cosine 2.5 with the x negative 1 inside the parentheses. So second cosine 2.5 x negative 1. You got her. 66.42 degrees. Any questions? Well, we covered a lot of stuff in the last few days. Okay, some of you are still working on the quiz, and that's fine. I'll have you set it aside. You can have some more time to work on it later. I want to take a look at our new material right now. So what we are going to be looking at is using this trigonometry on right triangles. We found, the functions from the right triangles as well as from the unit circle. But now let's look at how does it actually get used to find anything. Well, if I have a right triangle, I'm going to label it angles A, B, and C. So, of course, the sides get labeled according to the angle that they are opposite, the angle they are across from. So this up here is side C, the hypotenuse. We're used to C being the hypotenuse. That's why angle C is almost always the right angle. So the other two angles are angles A and B so that our legs can be A and B. And again, note, A is across from A, opposite A, and B is opposite of B. Well, if I were to tell you that angle A here were 38 degrees and that side C were 25 inches, I could find all the other pieces of this triangle. First, I could find angle B rather quickly. How do I find angle B? Perfect. Yeah, since the right angle is 90 degrees, I know there's 90 degrees left. So those other two angles have to be complements. So 90 minus 38 leaves us with 52 degrees. So finding angle B was rather easy. To find sides A and sides B, sides A and B, we look at what we know. Well, we have the right angle. That's not real significant. We know that angle A is 38 degrees and side C is 25 inches. Side C, now, of course, we're focusing on angle A. Side C is going to be what? Opposite, adjacent, or hypotenuse? C is the hypotenuse, right? It's always the hypotenuse in this. We are looking for, we want side A. Side A, according to angle A, is the opposite side. So we are dealing with opposite and hypotenuse. What trig functions do we have that deal with opposite and hypotenuse? We have cosecant. Yes, I put the wrong one in there. Cosecant of theta is hypotenuse over opposite. We don't have a cosecant in our calculator. I'm going to try to avoid using the cosecant function because I don't want to do the extra keystrokes on my calculator. But there is one other one that involves opposite and hypotenuse, and that is the sine. There's my winner. I have that key on my calculator. So what I'm going to do is I'm going to write out the definition of sine. Sine theta equals opposite over hypotenuse. And then I'm going to fill in what I know. Do I know theta? Yeah, that's angle A. That's 38 degrees. Do I know the opposite side? No, that's what I'm looking for. That's side A. I know the hypotenuse is 25 inches. Now, remember when we defined these a couple days ago, it was always as a proportion like that. The trig function was over 1. A lot of times these are easiest to work with if you have them like that. So now to find A, it's just cross multiply and divide. Sine of 38 times 25 divided by 1. So I do sine of 38. Most calculators, you got to close the parentheses. Times 25. And then really, we know we don't really need to divide by 1. Because it's 15.39. So that's telling me up here is A is 15.39 inches. To find side B, I have a couple of options now. One of those options A squared plus B squared equals C squared. I am going to kind of dissuade you from this option right now because C was given. We know that's exact, 25 inches. But what about A here? Yeah, it's got an ugly decimal. We just calculated that. And the 15.39 is rounded off. It's really 15.3915368, blah, 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 blah going on. We don't know really. We don't have an exact number for that. So I would rather than using that number I just calculated, that at the very best is rounded off. At the very worst, I made a mistake calculating it. I'd rather go back whenever possible to information that is given to me. That way I'm not using calculations to do more calculations. So I avoid compounding the round off errors, and I avoid that possibility that I may have made a mistake on my first calculation. But that A squared plus B squared equals C squared is one way to do it. But let's look at this. If we're trying to find side B, we still know the hypotenuse, which is side C, and we still know angle A. If we are looking for, we want side B. Side B is what side according to the angle we're looking for? We have angle A here. Side B is adjacent. So we have the hypotenuse and the adjacent, which secant would be a possibility, right? But we don't have that secant button, so yes, you are correct. The cosine is adjacent over hypotenuse. That's the one we really want to use. So again, we'll write out that definition of cosine. Cosine theta is adjacent over hypotenuse. Put in the information we have. Cosine 38 degrees equals adjacent side is B over the hypotenuse of 25. Put this over 1, and it's going to be cosine of 38 times 25. So cosine 38, close the parentheses, times 25. 19.70. So 19.70 inches. Now, I keep this little ace in the hole. If I want to double check myself, that better be true, right? Or at least really close. 19.7 squared plus 15.39 squared is 624.94. Well, 25 squared is 625. That's close enough. That's just a round off errors. So if I'm given, obviously I'm always given a right angle because it's a right triangle. If I'm given a side and one angle, this is the process. Obviously, the third angle is easy to find. It's the sides that need the trig functions. If I am given, obviously given the right angle because it's the right triangle, if I am given two sides, let's say I tell you that this here is, somebody give me a number between 8 and 15. 12, okay? So we're told that side little a is 35 and little b is 12. So I'm given two sides. Now I don't know any angles. To find side C is real easy. C squared is equal to 12 squared plus 25 or 35 squared, right? So I'm just going to punch it in. Second square root 12 squared plus 35 squared. Better give me 37. And it does. C is 37. Now again, I'm going to go back to the information I'm given, the 12 and the 35. And I'm going to pick an angle. Which angle do I want? Angle A, okay? If we're looking at angle A, trying to find angle A, we know B, which is which side according to angle A? It's adjacent. It's right next to it, right? And A, the 35, which is which side? It's the opposite. Opposite and adjacent can either be cotangent, which is adjacent over opposite, or tangent, which is opposite over adjacent. Which one do we want to use? Tangent is a button on our calculator. So let's write this out. Tangent of theta equals opposite over adjacent is the definition. Fill in what we know. Tangent of A is what we're looking for, equals 35 over 12. So now before, we were looking for a missing side. We just made it a proportion and we cross multiplied and divided. We got that missing side. Down here, we are looking for a missing angle. When we're looking for a missing angle, we get something like this. Tangent of A equals this fraction. Remember yesterday when we had tangent of A equals a decimal or whatever, how did we solve for A? Inverse tangent. So the tangent and inverse tangent cancel out. That just gives us A. Over here, we've got inverse tangent, which is second tangent. Now mine puts the parentheses up there automatically. If yours doesn't, you will need to open a parentheses here. 35 divided by 12, and then close the parentheses. Hit enter, 71.08 degrees. Rounded to two decimal places. What do you think? Almost. We will spend more time going over these next week. We're going to get this started now, so you got a little time to finish up that quiz, page 351 through 354. In your new packet is going to be problems finding missing parts of these triangles.